Hello, welcome to the Chemistry Made Simple podcast. I'm your host, Matthew Macario, and this is the podcast where you get chemistry confident and ready for that grade A. Hello and welcome back. This is the 5th episode in our series on organic chemistry, and today we're going to be talking about the family of organic compounds called alkanes. We're going to define what alkanes are, we're going to talk about their general formula, the possible structure types, and the chemical properties too. So alkanes are what you might consider to be the simplest of organic compounds. They only have carbon and hydrogen atoms present, and alkanes fall into the category of saturated compounds. Saturated means all their bonds are single bonds, and so the atoms are bonded to as many other atoms as they possibly can be. Alkenes have the general formula CnH2n plus 2, where N is the number of carbons. If we think of the simplest of the smallest alkane, methane, that has one carbon, so N is 1. That has one carbon and 4 hydrogens. And that follows the formula Cn, there's one carbon, H2n plus 2. So 2 times 1 plus 2 would be 4, so CH4. And you could do that for most alkanes. We'll talk about one exception later in this episode. In terms of structures, those carbons might be all in one straight chain, an unbranched chain. And we consider those molecules to be linear. Technically, they're not quite linear, but they are considered as linear as can be. We can also have branched chains where some of the carbons are in a single chain, but at one or more positions, one or more carbon atoms along the chain, there will be a branch to more carbons. And we alluded to this a little bit in the previous episode about isomers. So if you go back and listen to the section on chain isomerism, that goes into it a little bit more. It's also possible to have ring alkanes. This is where the carbon atoms are joined together in a ring. There's no end carbon. And this, in fact, is the exception to the general formula. Where we have a ring alkane, the general formula is CnH2n. There is 2 hydrogens less in a ring alkane. An example of a ring alkane would be a compound called cyclohexane, which has formula C6H12. There are 6 carbons forming a ring, and each carbon is also bonded to 2 hydrogen atoms each. When it comes to naming of alkanes, we talked about naming of organic compounds in a previous episode, and I'll put a link in the show notes to that episode. So that brings us to talk about the physical properties of alkanes. We've talked about electronegativity and polarity in an earlier episode. Again, I will put a link in the show notes. Alkanes are considered nonpolar because the electronegativity of carbon and hydrogen atoms is very close. So the polarity of the carbon to hydrogen bonds is very low indeed. We consider it to be nonpolar. The carbon to carbon bonds present, of course, are nonpolar because there is no electronegativity difference between 2 carbon atoms. In terms of boiling points are very low for the smallest of the alkanes. In fact, methane, ethane, propane and butane are gaseous at room temperature. The boiling points increase as the size of the molecule, the mass of the molecule increases. That is a function of increased intermolecular forces between adjacent molecules of whichever alkane. It's worth noting as well where we have a situation of an isomer of straight chain compared to a comparable isomer of a branched chain alkane that has the same chemical formula. The straight chain compound will have a higher boiling point, and that again is because of intermolecular forces. Where a compound has molecules with straight chains, there is a larger area of contact between adjacent molecules. Where there is a branch, that branch causes a spatial separation of molecules to some extent and reduces the van der Waals, the intermolecular forces between molecules of that isomer, and therefore the boiling point won't be as high as it is with the straight chain equivalent. Another consideration is that alkanes are insoluble in water, and that's no surprise because water is a polar solvent, and we already mentioned that alkanes are very non-polar. You're probably aware that like dissolves like when it comes to polarity. So let's think about what we've talked about today. We've said alkanes are saturated hydrocarbons. They have only single bonds and only carbon and hydrogen present. The general formula is CnH2n plus 2, where N is the number of carbons in the molecule, with the exception of ring alkanes that have the formula CnH2n. We talked about variations of structure. We have straight chain, we have branch chain, and we have ring alkanes. We talked about the physical properties. We talked about alkanes being very nonpolar because of the very small electronegativity difference between carbon and hydrogen. We also said that because alkanes aren't polar, they are very insoluble in water. And we talked about boiling point increasing with increasing molecule size, and that straight chain molecules tend to have higher boiling point than branch chain molecules because branches interfere with the intermolecular forces. They interfere with the amount of contact between adjacent molecules. So in our upcoming episodes, we're going to talk about combustion of alkanes. We're going to talk about making halogenoalkanes. So I look forward to telling you about those. Make sure you're subscribed so you don't miss that. If you want to get in touch, I'd love to hear from you. You can find me on Instagram at Chemistry Made Simple. If you have questions about this episode, consider joining our patrons in our Patreon community, where I'll be inviting you to submit questions on this and other episodes and then answering those for you. I'll put a link in the show notes to that as well. And the cost of that is about the cost of a coffee each month. And it does go to support the show's costs as well. All that's left for me to say is don't forget to review what we've talked about today. I look forward to speaking to you again in the next episode. And until then, do look after yourself and goodbye. Maybe what we've talked about today has sparked some questions, or you had some questions on this topic anyway, and you're still looking for an answer. Well, I'd go deeper and answer more questions for the show's patrons after each episode now. And you can become a patron very easily and for about what you'd pay for a coffee. You can find out more by going to patreon.com/chemistrymadesimple. That's patreon.com/chemistrymadesimple. And that link is in the show notes too. Once you're a patron, you'll find that I invite questions after each episode, so you're not left wondering. So I'll see you in that Patreon membership soon. Go there now.